Economists study how different forces in an economy interact to produce different outcomes. If you've ever taken an economics class, you know this means a whole lot of math. Though the basic concepts of economics, supply, demand, savings, investment, are familiar, understanding the mathematical principles that connect them can be challenging. A big part of the challenge is that economic principles are so abstract. What if there were a way to make them concrete? What if you could see the principles in action? In the 1940s, an economist from New Zealand named Bill Phillips built something extraordinary, the MONIAC machine, a hydraulic computer that modeled the entire British economy using water. MONIAC stands for Monetary National Income Analog Computer. Phillips, a former electrical engineer, wanted to make economics more concrete. His creation brings the invisible workings of an economy to life. The MONIAC uses water to represent money. At the bottom is a holding tank, which represents the total amount of money in the economy. This water is pumped to the top to represent national income. From there, the water flows through various pathways. Taxes are diverted to the left and sent to the government area of the machine. Some of the remaining water flows to savings on the right, while the rest flows down the central tube, which represents consumption. Each of the separate flows then go through a series of chambers and valves representing different economic forces. Eventually, it all returns to a central tube that represents total domestic spending. There's a complex mechanism for the effects of imports and exports, as well as other mechanisms to represent debt spending, interest rates, money printing, and so on. Finally, all the water returns to the bottom tank, where the pump recirculates it back to the top to complete the cycle. The flow of water through the system represents the complex interrelationship between different aspects of the economy. You can even connect several MONIAC machines together to simulate how different national economies affect each other. The MONIAC machine was a very powerful teaching tool at the time of invention. It was even used by economists to help resolve theoretical questions and to develop policy proposals. Let's take a closer look at how it models savings and investment. The water that flows into the savings tank represents the portion of national income that households and businesses don't spend immediately. The valve at the bottom of the tank is carefully calibrated to determine how much water flows out of savings balances and into investment. If the valve is closed, that is, if savings aren't converted into investments, water will accumulate in the tank, which keeps it out of the rest of the machine. Eventually, the flow of water through the whole system will slow to a trickle, which represents an economic slowdown. So we need to keep the investment valve open to ensure a smooth flow of money through the economy. On the other hand, even if the investment valve is wide open, we have to make sure that we're saving enough. Too much consumption will drain the savings tank and leave nothing left for investment. The MONIAC machine's system of pipes, valves, and tanks serves as a powerful analogy for the relationship between savings, investment, and economic health. Today, we no longer build scientific models out of pipes and tanks. But while modern computer models are much more advanced than Bill Phillips's machine, they all help us reason about the real world by creating a simplified model that's easier to study than the real thing. The strength of any model depends on how closely its functions mirror the real-world systems it represents. The MONIAC uses tubes that represent taxation, savings, investment, and consumption. Just as in the real-world economy, the government taxes people's incomes, people save what they can or want, some of the savings end up being invested, and people spend their money on goods and services. The tighter the analogy between the model and the world, the more powerful the model is. Every model, whether physical or digital, has limits. The MONIAC's water flows steadily and mechanically, while real economies are shaped by unpredictable decisions, innovations, and external forces. For example, the model can't account for panic in the stock market. Failing to understand a model's limits can lead to overconfidence in its predictions. The MONIAC can't account for the complexities of consumer psychology, policy decisions, or crises that drive real-world change. Models and analogies like the MONIAC help us to see patterns and relationships. They provide insights that are hard to grasp and can help us make much better predictions. But their strengths are also weaknesses. By simplifying reality, they risk oversimplifying it. Their power to illuminate can obscure crucial details. And if we rely on them too much or in the wrong ways, they can seriously mislead us. Models and analogies are very powerful tools for reasoning and shape our understanding of the world. Using them well requires understanding how they work and how they can give us evidence and insight about the world, as well as how they can't.